So why Raspberry Pi? Well, the name Raspberry Pi follows the tradition of computers that have named themselves after some kind of fruit. So that's where the raspberry comes from. And the Pi is from the Python language, which is the programming language. So I finished my explanation. I can go home now, right? It's about the size of a pack of cards. It has taken the optimization that has happened in downsizing the size of chips and everything, and put that all on a single board and made it a device that can be programmed for use very cheaply. And it has done what many, excuse me, many hobbyists would like to use. So its main goal was to help young people discover computers at a low cost, but it soon became popular for other uses. It's commonly programmed in Python. It runs the Linux operating system from an SD card that's inserted in the board, so you don't see hard drives attached to these things. It's powered from a USB charger, typically. Small power device. It's therefore silent. It doesn't require a fan usually, and it's very low power. So it acts as a very low power server in some cases. Along the back here, you can see the pins that are the general purpose I/O pins that make it different from other devices. So like most computers and smartphones, it has an HDMI. Well, smartphones don't have an HDMI, but most PCs have an HDMI that connect to a display. It has USB keyboard and mouse that you would connect to it. It has an Ethernet jack. It has Wi-Fi, and it has a speaker jack. It lacks a case, a fan, and internal power supply. But that 40-pin header includes 28 multi-purpose input-output pins, and I've shown a picture of that, a diagrammatic picture of that. So you get 5 volts, you get ground, and then you get 28 general purpose I/O pins, which are connected to external devices. It has a camera header, and it's often run without a monitor and keyboard attached via SSH or VNC. A lot of times people put these hardware added to the top boards are plugged into that 40-pin connector on the back. And also people can make their own hardware added on top. They contain typically a variety of sensors and the controllers. Controllers are like these relays here. So you can control 4 AC powered devices with this hat that's plugged into the Raspberry Pi. People use this to do control of watering systems, like the sprinkler systems and things like that. That's a common use for it. Because of this ability to add hardware to this device, a large maker community has developed hardware and software, and a lot of copy and paste practices have enlarged the community tremendously. And because that's been so successful, this form factor of these 40 pins and the connectors has become a basis for many competing small single board computers. So this is called a single board computer, this piece underneath. And there's orange pies, there's other pies too. So this is a relay hat from BC Robotics. It's from a town that's in between Ron and myself, Nanaimo, and they design these and sell them. You can make your own do-it-yourself hats. So here I've made a little connector and plugged it onto the 40 pins, and I'm running it out. And although all these wires are here, only 3 are actually used to activate this relay. So makers often build their own hats by connecting manufactured generic modules to the 40-pin connector. This is a manufactured module that I purchased for under $2. And there's all kinds of these modules available, sensor modules and things like that. RPI controls actuators based on sensor data. So you'll sense temperature or brightness, time of day. You can sense mass or motion or dampness, electricity, current, things like that. So based on all of these sensors, you can make up an algorithm that says, well, when these conditions exist, I want you to turn on a light or a heater or an alarm. That was my first use of this, was actually to build an alarm system for my house. I had a bunch of sensors around the house, and I would send myself a text message when I was not in the town that something was going on in the house that shouldn't be. You can log that sensor data if you're, for instance, making a weather station out of the device. You can log it, and you can also display that on a web page. Here's a picture of a weather station that is using a Raspberry Pi. You can use it as an appliance without the hats. To me, that's not the appeal. The appeal of this device is that you can add the hats to it. And, you know, I'm an popular electronics reader. There were a lot of us in the early, 1960s, 70s, 80s, who were electronic hobbyists, I guess, and we would build our own radios and stuff like that. And I think you could buy popular electronics in all of the stores. You could buy radio electronics in all of the stores. Those have disappeared. But this whole Raspberry Pi movement and other single board computer movements has rejuvenated that community. So we are all doing stuff with that. And those communities exist right around the world. But without the hats, you can run it as a desktop PC. This is a picture of a desktop, and there's the drop-down menu of typical functions of a computer. You can use it as an ad blocker attached to your modem or router. Then it will swallow up the adverts and prevent them from being on your computer. You can use it as a wireless print server for older printers. These are the most common uses that people make of a Raspberry Pi without a hat. A media player is pretty common. People use them like that. And game server, a retro game machine, security camera. If you use it for one purpose, let's suppose you use it in the summer to turn on fans and stuff like that. Well, in the winter, you can reuse that device by unplugging that hat and plugging another hat on top. So then Raspberry Pi brought out a smaller device called the Pico. It's a microcontroller. So there's a difference between a microcontroller and a single board computer. The microcontroller does not run the Linux operating system. And it still is programmed with Python, the programming language, and it still has all these GPIOs, these general purpose IO connections that you can connect to external modules. But it runs much lower power. You can run this off batteries. And so this is what is an interest also for many people. This has come out in the last couple of years. Now, the availability of the single board computer, the Raspberry Pi 4, has been simply unavailable. It has been so popular that they cannot keep up with the availability. They say they're going to fix that problem this year. But in the meantime, there's many other types of single board computers that use the same form factor. And I think they'll even run the same operating system. So that's the end of my piece. Let me stop sharing.
By full screen it, there we go. And also well, I'll just
Powerless, coping with a failed UPS in a critical moment. I'm Hewie Poplock. A few weeks ago on Tech for Senior, I was to do 2 presentations. As I was about to start my first one, all of a sudden, my computer went away. Everything was dead. I was so embarrassed, but I couldn't do anything. So my part of the Tech for Senior program that Monday went away. We just weren't able to use it. My power didn't shut off, but my computer and UPS did. When the power goes out, the UPS, or uninterruptible power supply, should provide temporary power to my computer and other connected devices until I can safely shut them down. However, if the power outage was sudden and the UPS was not able to switch to battery power fast enough, it's possible that my computer shut down before the UPS could take over. It's also possible that the UPS battery was drained or malfunctioned, causing it to shut down and cut power to my computer. In this case, I may need to replace the battery or the entire UPS unit if it's not functioning properly. And I was convinced this was my issue. You see, UPSs have a spec called switchover time that's different for each one of them. Simply put, it's the time taken by a UPS to switch over to its battery backup in case of a power failure. There is always a small delay, about 5 to 10 milliseconds, before the battery backup can pick up the load of the computer. During this small delay, the power supply to the PC is entirely cut off. The PSU, or power supply unit, of the PC is supposed to compensate for this short power loss by discharging its capacitor so that the power to the motherboard and all peripherals are not interrupted. Here's a chart talking about that. But that wasn't my issue. This was the UPS that I had. It's a APC Backups XS1300. And this is the back of it. I'm going to show you and talk about that a little bit more in just a few slides. The unit itself is no longer available. I think I've had it for about 10 years. It was discontinued in September. However, I can get replacement batteries for about $90. And these are what the batteries look like. They're heavy. They're a lot like an automobile battery. Here is the back of the UPS that died. And you will see that there's different plugs. If I had realized what was going on and I could get on the floor and of course get up, I could have probably unplugged those items in the battery backup outlets and put them in the surge protected outlets. I could have had my computer back up and running, but by the time I did all of that and then try to get up from the floor underneath my desk, it would have been time for everything to end anyway, so I didn't worry about it at the time. Some of those surge protected outlets are also being used, so I would have had to switch some things around. So it wasn't possible to do. So number one, input power. The UPS is connected to a power source, typically a wall outlet or a generator that supplies AC power. A rectifier, the incoming AC power, is converted to DC power by a rectifier. Then the battery, the DC power, is then used to charge a battery that's typically housed within the UPS. The battery is the primary source of power for the UPS. And then there's an inverter. When the power supply from the wall outlet or generator is interrupted, the battery takes over and the DC power is then converted back to AC power by the inverter. And then the output power, the AC power output from the inverter, is then supplied to the devices or equipment that are connected to the UPS. And there's an automatic voltage regulation. The UPS devices often include automatic voltage regulation, or AVR, that can adjust the voltage output to compensate for voltage fluctuations or spikes in the input power. This helps protect the connected equipment from damage. And I have suggested to some people who have power issues in their homes, they may have voltage regulation needed. The voltage may go up and down, and those would cause their computers to shut off and maybe reboot. So some of the times a UPS can solve some of those issues. The amount of time that a UPS can provide backup power depends upon the capacity of the battery and the amount of power that your devices are using. A large battery can provide backup power for a longer period of time, while devices that use more power will drain the battery more quickly. There are three main types of UPS systems. There's the standby UPS. This type of UPS is the most basic and economical. It works by monitoring the incoming power and switching to battery power if there's an outage or fluctuation. Standby UPS systems are commonly used for home computers and small office equipment. Line interactive UPSs. This type of UPS is similar to a standby UPS, but includes a voltage regulator to stabilize the incoming power. Line interactive UPS systems are commonly used for more critical equipment, such as servers, networking devices, and medical equipment. And then there's the online UPSs. This type of UPS provides the highest level of protection and is often used in data centers, hospitals, and other critical infrastructure. Online UPS systems work by constantly converting the incoming power to battery power and then back to AC power to ensure a steady and clean output. Here's what the inline systems for large facilities are like. Here's another one, and here is even another. Obviously, these are much more than you need in your home. It's important to note that a UPS is not a substitute for a backup generator or long-term power outage solution. A UPS is designed to provide temporary backup power for a limited amount of time. If you need to power your devices for an extended period, a backup generator would be a more suitable option. In addition to the loss of backup power, a dead battery in a UPS can also cause other issues. For example, if the UPS is not able to properly detect a power outage or voltage sag due to the dead battery, it may not switch over to battery power as intended. This could lead to an unexpected loss of power to connected devices or systems, potentially causing data loss or other issues. If the UPS fails to provide power after a battery failure, it may be necessary to replace the battery or the entire UPS unit, depending upon the severity of the battery damage and the age of the unit. It is also important to note that some UPS models may have safety features to prevent them from providing power when the battery is damaged to avoid potential hazards such as overheating, fire, or explosion. And I feel that this is what happened to me, that the batteries have failed in the UPS. If the UPS is still good, I can replace the batteries and it still should work fine. But it is a much older UPS and I'm going to have that checked as well. Here is what I replaced it with. I replaced it with an 850 volt amp. It is a Cyber Power. It was $109 and it has three different sections on the power strip. There's Eco Control, which when the UPS detects a computer is off or is in sleep mode, it'll automatically turn off power to computer peripherals connected to the Eco Mode outlets, reducing power usage and lowering energy. And then there's surge protected outlets that are only surge protected. If the power goes out, they go out. And then there's battery supported and surge protected. That means if the UPS goes to battery, those items plugged in there will work until the batteries deplete, and they're also surge protected. The Cyber Power UPS that I got came with a wire that I couldn't quite figure out what it was for until after I got everything plugged in and looked at the manual. I do read manuals. You plug it into the UPS on one end and to a USB on the computer on the other end. You install the software and it will give you status and information. Now here's what the current status of my unit looked like when I did it with the software. It said that I had 50 minutes of runtime and that I was only using 61 watts as a UPS load. Then if I looked at the summary, it told me the number of times that I had a power outage, or if I rebooted the computer, shut it off and turned it back on, it indicated that as a power outage because there was no power going to the computer. And then there were also event logs that I can take a look to see what's going on. Under energy reporting, I can see what the consumption is. I can also look at the voltage, and I can run a self-test to see if I have any issues. Here is the several models from the Cyber Power UPSs that they have, and I decided on the 850. In conclusion, a UPS stops providing power when the battery fails because the battery is the primary component that stores energy and provides backup power. Therefore, it is essential to regularly maintain and replace the battery to ensure the UPS functions properly and provides reliable backup power in case of power outages or other disruptions. Here's what the one looks like, and there are certain plugs that do certain things on it. This has been Powerless, Coping with a Failed UPS in a Critical Moment. I'm Hewie Poplock.
What is phishing, and can you protect against it? Phishing is a type of cyber attack in which an attacker tries to trick a victim into revealing sensitive information such as login credentials, credit card numbers, and personal information. Phishing attacks typically involve the use of emails, instant messages, or other communication channels that appear to be legitimate but are actually fake and designed to steal information from the victim. Phishing attacks can take many different forms, but they often involve a message that appears to come from a trusted source, such as a bank, an online retailer, or a social media website. The message may contain a link to a fake website that looks like a real one, or it may ask the victim to provide sensitive information directly through the message. Causes of phishing. Phishing attacks are usually motivated by financial gain or by a desire to obtain sensitive information that can be used for identity theft. Phishing attackers typically use social engineering techniques to manipulate the victim into taking some kind of action, such as clicking on a link, opening an attachment, or providing sensitive information. One common technique used in phishing attacks is to create fake websites or emails that look like they come from a legitimate source, such as a bank, social media site, or online retailer. The attacker may use convincing graphics, logos, and other elements to make the message or website look legitimate, and then use language designed to create a sense of urgency or fear, such as warning the victim of a security breach or threatening to close their account if they don't act quickly. Other techniques used in phishing attacks include spear phishing, which targets specific individuals with customized messages, and whaling, which targets high-profile individuals such as executives or celebrities. Protection against phishing. To protect against phishing attacks, there are a number of steps you can take. Be cautious of unsolicited emails or messages, especially if they contain urgent or threatening language. Phishing emails often use scare tactics to get you to act quickly, so it's important to take a step back and think before clicking on any links or providing any sensitive information. Look for signs that the email may not be legitimate, such as spelling or grammatical errors, or a sense of urgency that seems disproportionate to the situation. Verify the sender's email address or phone number before responding or clicking on any links. Phishing emails often use spoofed or fake email addresses or phone numbers to make the message appear to come from a legitimate source. Before responding to any message or clicking on any link, take a moment to verify the sender's identity by checking the email address or phone number. If you're not sure, contact the sender directly through a different channel to confirm their identity. Check the URL of any link in the message to make sure they match the website you expect to visit. Phishing emails often include links to fake websites that look like legitimate ones. Before clicking on any link, hover over the link to see the URL it leads to. If the URL looks suspicious or doesn't match the website you expect to visit, don't click on the link. Do not provide sensitive information in response to an unsolicited message. Never provide sensitive information such as your login credentials, social security number, or credit card information in response to an unsolicited message. Legitimate organizations will never ask you to provide this information through an email or message. Install anti-phishing software or browser extensions that can help detect and block phishing attacks. There are many tools available that can help protect against phishing attacks, such as anti-phishing software or browser extensions. These tools can help detect and block phishing websites, alert you to suspicious links, and provide other security features to help keep you safe. Use multi-factor authentication on all of your online accounts to add an extra layer of security. Multi-factor authentication is an important security feature that adds an extra layer of protection to your online accounts. By requiring a second factor, such as a text message or authentication app in addition to your password, multi-factor authentication can help prevent unauthorized access to your accounts even if your password is compromised. Keep your computer and devices up to date with the latest security updates and patches. Keeping your computer and devices up to date with the latest security updates and patches is an important part in protecting against all types of cyber attacks, including phishing. These updates often include security fixes and patches that can help prevent attackers from exploiting known vulnerabilities. Educate yourself and others about the risk of phishing and how to avoid falling victim to these types of attacks. Finally, education is key when it comes to protecting against phishing attacks. By learning about the risk of phishing and how to avoid falling victim to these types of attacks, you can help protect yourself and others from becoming a victim. Share this knowledge with your friends, family, and colleagues to help spread awareness about the importance of online security.